In this lesson, we discuss bump and normal mapping in Arnold for Cinema 4D. Using bump mapping, you can simulate grooves and imperfections like wood grain, for example, on a surface. Always remember when using bump mapping, unlike displacement mapping that we'll be taking a look at in the next lesson, you only simulate the effect of the grooves. You don't actually create and alter the geometry. So let's open up the shader that we have assigned it to the shader ball by middle clicking on it. In the shader tree, let's search for bump. As you can see, we have two bump nodes, bump 2D and bump 3D, with similar functionalities. The difference here is that you can use bump 2D node to produce bump mapping based on a 2D texture, and a bump 3D needs a 3D input. Let's drag a bump 2D node into the work area. You can see this node has three parameters: bump map, bump height, and normal. We need to define a map to be used as our bump map. So let's use something like a noise node and drag it to the work area and connect it to the bump map attribute of the bump 2D node. Now let's see how the noise looks on the shader ball by connecting the noise node to the Arnold Beauty port. Let's increase the scale maybe to something like 20. Now we need to connect our bump 2D node to the normal input of the standard surface shader and connect the standard surface shader to the Arnold Beauty port. As you can see, the bump mapping isn't quite visible. Let me just increase the bump height, which controls the amount of bump mapping, to about 4. Now you can clearly see how our noise texture causing bumpiness on our shader ball. Always remember that this is just an illusion. The actual geometry is not changing. Look at the outline. It's perfect. The silhouette is unchanged. Let's use a simple image here to derive our bump mapping. Let me search for an image and drag it to the work area. Let's load this wood parquet texture. So as you can see, where the texture is white, we see bumps, and where it is darker, we see indents. Also, you can simply use normal maps instead of these regular grayscale images. When you use a grayscale image as your bump map, you are only specifying two directions, up and down. But normal maps are RGB textures and can give a direction to the bumpiness effect. Even though you can load your normal map in a bump 2D node, but a better way is to use a normal map node. So let's search for a normal map and drag it to the work area. Let's control drag our existing image node, and let's load this normal map texture here and connect it to the input attribute of the normal map node. Now connect the normal map output to the normal input of the standard surface shader. Now let me select the image node and increase its scale U and V to 2. So as you can see, now we have this normal mapping effect going on our shader ball. We have a few options in the node, in the normal map node. First of all, we have strength, which increases or decreases the normal map effect. Tangent space specifies if the input is in wall space or tangent space. Then we have order, which lets you shuffle the input channels order. We have invert X, Y, and Z, which allows you to invert X, Y, and Z or R, G, and B channels. We have this very useful color to signed option. And for 8-bit maps, if this option is enabled, the input is remapped to the -1 to 1 range, so we can get more out of our normal maps. Now, if you have a tangent map from your sculpting app, you can actually connect it to these tangent input here. The normal and tangent parameters can be optionally linked to define a custom tangent coordinate system that the input is transformed from. And if the normal is not linked here, it will use the default surface normal. So that's about bump and normal mapping in Arnold for Cinema 4D. In the next lesson, we discuss displacement mapping.